Hello guys and welcome back to Mystery Truth. Yellowstone can expose huge underground plumbing network that has only scratched the surface. Airborne scans of the ground beneath Yellowstone National Park have helped shine a light on the hydrothermal plumbing that supplies its iconic geysers like Old Faithful. The Yellowstone National Park covers some 3,500 square miles of the United States and is home to some of the world's most iconic hydrothermal geysers and fumaroles. These include the iridescent colors of the Grand Prismatic Spring, the bubbling mud cauldrons that are the artist paint pots, and of course, Old Faithful, the magnificent cone geyser that erupts a spray of water and steam roughly every 44 to 125 minutes. As millions of tourists each year marvel over the park's many hydrothermal spectacles, so do earth scientists as they attempt to plumb the underground systems that formed and maintain them. In their study, geophysicist Prof Holbrook of Virginia Tech and his colleagues conducted special airborne scientific surveys of Yellowstone using a special instrument called SkyTEM, which consists of a large loop of wire suspended from a helicopter. The system, which emits repeated electromagnetic signals into the ground and measures the response of electrically conductive bodies, allowed them to identify areas underground with unusual electrical and magnetic properties. Professor Holbrook said, "The combination of high electrical conductivity and low magnetization is like a fingerprint of hydrothermal activity that shows up very clearly in the data. The method is essentially a hydrothermal pathway detector. By making repeated passes over the path, the team were able to probe the subsurface along some 2,500 miles of so-called helicopter lines, from which they could create stunning maps of the subsurface plumbing under Yellowstone that supplies geysers such as Old Faithful." Professor Holbrook added, "One of the unique aspects of this dataset is its extensive coverage of this huge system. We were able not just to look deep beneath the hydrothermal features, but also to see how adjacent features might be connected in the subsurface across great distances. That's never been possible before." The researcher found that, perhaps unsurprisingly, the nature of Yellowstone's hot springs are profoundly influenced by the geology of the vast national park. Hot hydrothermal fluids comprising both water and dissolved gases and minerals were found to ascend vertically from depth of more than 0.6 miles into the park's major hydrothermal field, traveling along faults and fractures within the rock. As they complete this journey, the fluids mix with the shallow groundwaters that flow both beneath and within the park's lava flow deposits. According to the team, the findings help to fill a long-standing gap in our understanding of the deep hydrothermal system that fuels Yellowstone's iconic geysers and fumaroles. Previous studies have examined the park's surface hydrothermal features, such as, for example, the eruptive interval of the geysers, the chemistry and temperature of the mud pots and springs, and the unique bacteria that thrive in these extreme environments. Others, meanwhile, have used seismic data to learn about the earthquakes and deeper heat sources far beneath Yellowstone. But little had been known about the exact nature of the connection between these deep fluid sources and the surface features. As Prof Holbrook put it, our knowledge of Yellowstone has long had a subsurface gap. It's like a mystery sandwich. We know a lot about the surface features from direct observation and a fair amount about the magmatic and tectonic system several kilometers down from geophysical work, but we don't really know what's in the middle. This project has enabled us to fill in those gaps for the first time. One such mystery the study has addressed concerns whether or not different hydrothermal areas of the park, exhibiting different chemistries and temperatures, might be supplied by different deep fluid sources. The team found that the deep structure beneath areas like the Norris Geyser Basin and the Lower Geyser Basin is remarkably similar, suggesting that the observed surface differences are actually the result of variable degrees for mixing with shallow groundwater. Paper author and geophysicist Dr. Carol Field of the USGS said, while the airborne data were still being collected, we saw the first images over Old Faithful and knew instantly that our experiments had worked. We could for the first time image the fluid pathways that had long been speculated. Our work has sparked considerable interest across a range of disciplines, including biologists looking to link areas of groundwater and gas mixing to regions of extreme microbiological diversity, geologists wanting to estimate volumes of river flows, and hydrologists interested in modeling flow paths of groundwater and thermal fluid. With the paper as a guide and the release of the data and models, we will enable research in these diverse scientific communities. The researcher's study may be complete, but Yellowstone still holds plenty of mysteries. The notion that airborne geophysical data could illuminate something about the life of microscopic organisms living around hot springs is a fascinating idea. Wow, what an interesting discovery. So whatever you have to say concerning this, drop your comments in the comment section, and please don't forget to subscribe to this channel. Thank you very much.